After completing Chapter 7, we saw how amazing our body metabolism is. When our diet doesn't provide enough energy, the body uses its glycogen and fat stores to meet glucose as well as energy needs. Also, what can happen is our lean tissue or our protein stores may also be broken down as a source of glucose as well as energy. When there is too much energy, think too many calories being provided, the body takes the excess carbohydrate, protein, and fat and stores it as additional body fat. In chapters 8 and 9, we'll talk more about this energy balance, more so in relation to weight management or weight control. The concept of energy balance is actually pretty simple. To maintain a certain body weight, calories or energy in equal calories or energy out. But what happens in a situation if more calories are consumed than those being expended or those being burned? Well, weight will increase. If it's a situation where there are less calories being consumed than those being expended or burned, weight will decrease. For years, what was used by health professionals was something known as the classic rule. This states that 1 pound of body weight is equal to 3,500 calories. So, in theory then, for each 3,500 calories eaten in excess, a pound of body fat may be stored. For each 3,500 calories expended or not consumed, a pound of body fat should be lost. We now know that there are limitations to this rule. Science has shown us that with the calorie restriction, weight loss occurs, then slows down as some individuals hit what we call a plateau. Simply continuing the same deficit or restriction may not be effective for continued weight loss. That initial weight loss often is not necessarily just a decrease in fat stores. Large amounts of fluid and lean tissue may also be being lost, and that will reflect on the scale. For some individuals, continued loss requires a further calorie restriction as their metabolism often changes. Specifically, the two populations which seem to be most affected by this issue of hitting a plateau are women and those who are in the classification of being obese. The classic 3,500 calorie rule then is not a successful method of weight loss, and individual metabolisms need to be taken into account. Often, the key to offset this type of a situation is physical activity, and we'll talk about the importance of this concept as we go further into the lecture. So just a quick review from Chapter 7, which was related to energy metabolism. The definition of energy metabolism is all reactions by which the body obtains and uses the energy from food. What we've learned from this chapter and previous chapters is that there are 3 energy-yielding nutrients: carbohydrate, fat, and protein. However, those nutrients need to be broken down to their most usable forms before they enter into the metabolic pathway. So carbohydrate needs to be broken down to glucose, fat needs to be broken down to glycerol and fatty acids, and protein needs to be broken down to amino acids. In this chapter, since we're looking at weight control, weight maintenance, we're going to review back again from Chapter 7 what happens when a person overeats or takes in more calories than what their body is expending. So we're going to take a look at the 3 energy-yielding nutrients. The carbohydrate that we consume is broken down in the body to glucose. Initially, the glucose is going to be used to build up our liver and muscle glycogen stores. However, note that some of that excess glucose will also be stored as body fat. Then let's take a look at dietary fat. That's going to be broken down into glycerol and fatty acids. That fatty acid component will very easily be stored as body fat. Then lastly, protein. Protein is broken down to the individual amino acids. Some of those amino acids will be used to make other body proteins, as we discussed in Chapter 6, things like hormones, neurotransmitters, enzymes, and so forth. But then look what also happens there from excess amino acids. If there are excess amounts over and above what's used to make body proteins, those amino acids will also be stored as body fat. So this diagram shows you that going over and above with calories from any of the energy yielding nutrients will cause us to store larger amounts of body fat. We know that to achieve energy balance, the body must meet its needs without consuming too many calories or too little calories. Appetite is a response that will prompt a person to eat or not to eat. You could see the definition of appetite is the integrated response to the sight, smell, thought, or taste of food that will initiate or delay eating. This response is different than hunger. Hunger is defined as an irritating feeling caused by lack of food that initiates food-seeking behavior. Think about how you feel when you're hungry. People will often refer to having almost a painful sensation in their stomach when they're hungry, or they experience being hangry, which can include being irritated yourself or just feeling weak or just out of sorts to some extent. There are physiological reasons for this feeling, and they can include: when did you eat last? Is there still nutrients present in your GI tract or in your bloodstream? Hormones also can influence this. Even things like illness or physical activity can also affect that category of hunger. The main area of your brain that plays a role in a physiological response to hunger is your hypothalamus. Also, your hypothalamus plays a role with two specific signals which cause us to either stop eating or start eating. Satiation is the signal which tells us to stop eating. It allows us to feel full during a meal. Satiety is a signal that tells us to not start eating again because we're experiencing fullness after a meal is concluded. Take a few minutes to follow the cycle of hunger, satiation, and satiety. Note the physiological, sensory, and cognitive influences that drive our decision to eat. Then there are also the post-ingestive influences that start to trigger that feeling of satiation or fullness that occurs during a meal. If we listen to these signals, it will tell us to stop eating. Then there are also post-absorptive influences that are involved in the continued feeling of fullness after a meal, or more specifically, satiety. Satiety plays an important role in determining how much time passes between our meals. Foods can provide either satiation or satiety effects based on what the composition of the food actually may be. Of the three energy-yielding nutrients, protein is considered to be the most satiating. High-fiber foods also can provide satiation by filling the stomach and delaying the absorption of nutrients. For this reason, eating a large salad, often as a first course, helps a person eat less during the meal. Fat, on the other hand, has a weak effect on satiation. High-fat foods may actually lead to what we would call passive overconsumption. Although it provides little satiation during a meal, fat, however, can produce strong satiety signals once it enters into the small intestine. Fat in the intestine triggers the release of certain hormones. One in particular is cholecystokinin, which is a hormone that signals satiety as well as inhibits food intake. Remember that I had also mentioned that the hypothalamus has been identified as the control center for eating. It amazingly pulls together all these signals which influence our eating patterns. In fact, in the brain, just recently, there has been a brain chemical identified, which is known as neuropeptide Y. What this can do is actually play a role in both appetite and hunger. This particular brain chemical has been identified as far as increasing carbohydrate cravings, initiating our urge to eat, as well as decreasing energy expenditure or calorie burn, which therefore then increases fat storage. All these factors then favor what we would call a positive energy balance and therefore weight gain. Even with brain chemicals and hormones telling us we're full and to stop eating, we often override these signals. Think about sometimes maybe if you're stressed or you're bored or you're anxious, often one of the things that we'll do is turn to food. Even if we're happy or celebrating, often food is going to be involved. There are also external cues, environmental influences, which include things like what foods are available. The sight of food can make us have a desire to eat it even though we are full. The taste of food, portion sizes all come into play also. As far as another example, think about if you are out to dinner and somebody comes around with a dessert cart or a dessert tray. You are full. Your brain is telling you that you are full, yet often we override that signal and we'll go ahead and have that dessert anyway. There's also cognitive influences that come into play, memories. Back in chapter 1, we mentioned the effects, the psychological effects of emotions coming into play. So happy memories often can be associated with comfort foods. Also social interactions set us up often for large amounts of food being available. And again, even though we might not be hungry, we override those signals that are telling us we should really not be eating. So what happens then when we continuously override those signals? Well, we gain weight. Being overweight or obese has increased dramatically, not just in the United States, but as well as in other industrialized countries. Being overweight or obese in of itself is an issue, but then there are also the many chronic diseases which are associated with carrying around that excess weight, and we will address some of those conditions also. How severe is this issue of the population being either overweight or obese in the United States? Well, if you take a look at this pie graph, what you'll see is that approximately 2/3 of our population is in one of those two categories, either being overweight or obese. So obviously it is a very serious issue. This slide portrays an even more specific depiction of the obesity issue in the United States. The map on top is the United States in 2011. Fast forward only 4 years, and the map on the bottom is the United States in 2015. Just focusing on the states which are colored orange or red shows the increase in obesity over this particular time frame. These orange or red colors show states where greater than 30%, or approximately a third of their population, have people who are categorized as being obese. So if we count up those two colors in 2011, there are 12 states that fall under this category. In 2015, again, only 4 years later, there are 25 states where greater than 30% of the population are classified as being obese. Now, this slide only goes up to 2015. We are now approximately 5 years past that, and it's estimated that the amount of states are currently around 35 to 40 where the population is obese. 30% of the population is obese. This increase in obesity is really taking a toll, not just on overall health, but our healthcare system. Some of the diseases which have increased dramatically, again in the United States, type 2 diabetes, heart disease, breast cancer, hypertension, osteoarthritis, stroke, fatty liver disease, as well as overall body inflammation. Then we also have to consider the toll on the healthcare system itself. With an increased incidence of these chronic diseases, then it leads to an increased rate of disability and overall increased medical costs. How can we determine then what one's weight classification is? Well, that's where the BMI comes in, the body mass index. The BMI is a measure of a person's weight relative to their height. Now, it doesn't take into consideration body composition, and I'll talk about that in just a minute. The body mass index gives you a range of what we would consider to be healthy weights for an individual. Now, to determine your BMI, you can use a formula, or you can use a BMI table, which we'll take a look at on the next slide. Once you determine what your number is, you can be placed in a certain weight classification. And you could see that based on your number, you might be considered to be underweight, of a healthy weight, overweight, or obese. There's another category too, greater than 30, which would put someone in the morbidly obese category. Then another positive to note with the BMI is that it can give you an idea of what your disease risk is. And this would be disease risk for those chronic diseases. So hypertension, diabetes, and so forth. Based on what your BMI is, determines if you are at a low risk for those chronic diseases or if you are at a high risk for those chronic diseases. So as I mentioned, that the BMI reflects height and weight measurements, but it doesn't take into consideration body composition. There may be certain populations where the BMI isn't going to be entirely accurate. So for example, an athlete who happens to have a high percentage of muscle or lean tissue, their weight is going to be higher, and based on their BMI, they may actually be considered to be overweight. But they're not overweight due to excess fat or excess adipose tissue. So there's an example where the BMI, again, might not be entirely accurate for all populations. Let's take a look at a BMI table and how you determine what your weight classification may be. So, for example, we're going to have somebody who is 5'10" and weighs 200 pounds. So the first thing we're going to do is go down to the far left under the height column and find the height of 5'10". Then we're going to go directly across the row, follow 5'10" all the way until you find the closest weight to 200. So in this case, we're going to follow 5'10" all the way across, and you could see the weight of 200 would be between the 195 and the 202 range. That is going to put this person's BMI then between 28 and 29. That BMI would then classify them as being overweight. As another example, let's consider that we have someone who is 5'6". So again, you're going to go down that height column until you find 5'6". They weigh 135. So now follow 5'6", that row directly across till you find the weight closest to 135. So in this case, it would be between 130 and 136. The BMI then would be classified as somewhere between 21 and 22, which would be considered of normal weight. So you could take this BMI table and go ahead and insert your own height and be able to figure out what your range of weights should be, healthy body weights should be. Knowing your BMI is important, but what also comes into play when determining health risks associated with excess weight is where we tend to carry that excess weight. Central obesity is a term used when there is excess fat around the trunk or the central part of the body. It's also referred to as abdominal fat or upper body fat. People who tend to carry more of their excess fat in that area are usually referred to as having an apple shape, and we'll take a look at that on the next slide. Carrying excess fat in the central area of the body is associated with those increased risks of chronic disease. So again, heart disease, hypertension, diabetes, and stroke. Then there is the population which carries more so excess fat in the lower area of the body, say in the hip, thigh, buttocks area. And often they're referred to as having a pear-shaped, and again, we'll take a look at that on the next slide. Having excess fat in this area is actually associated with a lower risk of developing those chronic diseases that I mentioned. Here you can visualize the apple and pear body shapes. On the left, from the outline of the apple, you can see that depicts that central obesity, a greater percentage in the abdominal area and upper body area. Whereas with the pear shape, you can see that there's a greater percentage of body fat in the lower area. The greater issue with those who have central obesity or that classic apple shape is that they also tend to have a greater percentage of visceral fat. So if you look at the depiction on the far right, you can see that there is a layer of fat right under the skin, right under the layer of the skin. That's referred to as subcutaneous fat, and that in and of itself has some health issues. But it's the visceral fat, which is the fat that you can see that starts to actually infiltrate around the organs. That puts a strain on the organs themselves and is related to an increased risk of some of those chronic diseases. A healthy percentage of body fat has been determined by various health organizations, and this table depicts what those healthy ranges may be. You could see that these percentages are divided up based on gender, and they're divided up based on age. What you really want to take a note of, however, is what the actual U.S. average is of body fat compared to what's considered to be healthy. What you'll note is for every single age group that the average is well above what is considered to be healthy. Again, going back to the fact that a large percentage of Americans are in that BMI classification of being overweight or obese. A simple indicator of fat distribution and central obesity is to simply take a waist circumference. A greater percentage of body fat is assumed when a female's waist is measured to be greater than 35 inches and a male's waist is measured at being larger than 40 inches. They will then fall under that category of having central obesity, and with it, that increased risk of chronic disease. In our textbook on page 246, which corresponds to figure 810, there are other methods which can be used to estimate body fat percentage. I noted previously the concept of energy balance in regards to calories in versus calories out. This is now going to lead us to energy expenditure. Energy expenditure is simply the amount of calories we burn, and the energy expenditure includes three components. It includes our basal metabolic rate, which is our BMR, physical activity, as well as what is known as the thermic effect of food. Now, energy expenditure will vary from one individual to the next. What will also affect it is age, gender, weight, height, as well as one's activity level. Let's talk about that first component of the energy expenditure requirement, and that's the BMR, or the basal metabolic rate. Your BMR is the rate at which the body expends energy, very simply uses calories, for what we would consider to be life-sustaining activities. So for your heart to beat, your kidneys to filter out, your brain to function, your lungs to function, they all are going to require a certain amount of calories to be expended. The BMR makes up the highest percentage of total energy expenditure. It's estimated to make up about 50 to 65%. Now, there are many factors that can raise as well as lower one's BMR, and we're going to take a look at these. In this table, you can see the many factors that affect the basal metabolic rate, and they include one's age, height, growth patterns, body composition, fever, stresses, environmental temperature, is one fasting or in a period of starvation, malnutrition, as well as certain hormones can all have a dramatic effect on either increasing or lowering one's BMR. And you can see again from this table which effect they might exhibit. A few other factors to note that can affect the BMR: smoking, nicotine in general, caffeine, as well as sleep patterns can all have an effect on this particular rate. To determine one's BMR, there are formulas which have been developed, and they differ based on gender. What you're going to do is just take these formulas and insert your weight, your height, and your age. By plugging in these numbers, your BMR will be determined, which once again is the amount of calories you expend on a regular basis for life-sustaining activities. Again, heart function, brain function, lung function, and so on. Take a look at this slide, and there is a specific example given for a 45-year-old female who is 5'6" and weighs 152 pounds. By plugging in those values, you could see that this particular BMR then is determined to be 1,352 calories. Physical activity is the second component which makes up the estimated energy requirement. Physical activity
takes up about 30 to 50% of all energy we expend on a regular basis. If one is performing more activity, well then obviously they're going to expend more calories. Of the three factors which make up the estimated energy requirement, physical activity tends to be the most variable. It's really based upon an individual's physical activity or exercise pattern. The third component is what's known as the thermic effect of food. And very simply, this is the amount of calories that are expended to process food through your GI tract. So digestion, absorption, transport, metabolism of nutrients, all will burn calories. It's estimated that approximately 10% of all the energy we expend, again on a daily basis, is from the thermic effect of food. However, when calculations are being done, this particular category usually is not used to estimate the final number of one's true energy expenditure. We do know that thermic effect is highest for foods that are high in protein. So basically we burn more calories from the digestion, absorption, metabolism of high protein foods, and we will expend the least for foods that tend to be highest in fat. How do you determine your estimated energy requirement? Well, once again, there are formulas which have been developed. And similar to the BMR, you basically insert your height, your weight, your age, but in addition, you will also insert a physical activity factor. Doing these calculations involves conversions, and you can see on the bottom of the slide the conversions of putting your weight into kilograms is noted, as well as putting your height into meters. Determining which physical activity factor you will insert into the estimated energy requirement equation depends upon how active you are. Are you sedentary? Are you lightly active? Are you active? Or are you very active? If you look at this particular table, you could see that there are certain factors assigned to each one of these levels. Once you decide what your level is, you will then insert it into the actual equation. As an example, let's look at a 30-year-old male who is 5'11", weighs 178 pounds, and has determined that their physical activity factor is 1.25. Well, the first thing that we need to do are the conversions. So we need to take the height and convert it into meters. So you can see you're going to divide the height in inches by the conversion factor of 39.37. Then the weight needs to be converted into kilograms. So very simply, 178 divided by 2.2 will give you the weight in kilograms. Then all the values just get inserted into the equation itself. Once those are all inserted, then we can start the calculation, and we have to pay attention to the order of operations. We're going to do the calculations within the parentheses first, then the calculations within the brackets, then multiplication, then addition, to finally get us to the determining estimated energy requirement of 3199 calories per day. So we'll round it up to 3,200 calories. That's the amount of calories that this particular male expends on a regular basis. And if he's trying to maintain his weight exactly where it is at 178, that's also the amount of calories that he wants to intake. Remember, calories in versus calories out. will allow weight maintenance. However, suppose he wants to lose some weight. What can he do? What would be an appropriate deduction? Well, for weight loss, general method is to simply subtract 500 calories. By subtracting 500 calories per day, that would bring him down from 3,200 calories to 2,700 calories per day. With that deficit of 500 calories per day over the course of 7 days, it would be a total deficit of about 3,500 calories, which ideally then would be equivalent to a pound of body fat that he should lose. If we know the basic principles then of calories in versus calories out, why do so many people struggle with their weight? From this next section that we're going to cover, we're going to discuss some of the issues involved in fat cell development. We'll take a look at genetics, body proteins, that unfortunately may be working against us. So the first thing we're going to take a look at is this fat cell theory, this fat cell development. When energy in exceeds energy out, much of that excess energy is stored in the fat cells of our adipose tissue. The amount of fat in adipose tissue reflects both the number and the size of the fat cells. The number of fat cells tends to increase most rapidly during our periods of growth, especially during the period of late childhood and early puberty. After we stop growing, fat cell numbers may still continue to increase whenever energy balance is positive. So these fat cells can increase in size 8 to 10 times their normal size, and then they'll start to increase in number again. If someone loses weight, the cells will shrink, but the fat cell number does not change. It remains the same. There are some methods which can be used to actually get rid of fat cells themselves. If anybody is familiar with liposuction, that certainly is a way to remove those fat cells. And there's some other methods which are also being developed. It's very easy to regain weight that has been lost because those fat cells, which, as I mentioned, we are going to have for the rest of our lives, they very easily can readily refill with triglyceride if our intake, once again, exceeds our energy expenditure. Take a few moments to look at this slide, which gives you a great visual of fat cell development. There is an enzyme known as lipoprotein lipase, which plays a major role in the metabolism and transport of fats and is considered to be a participant in the development of obesity. One of its major roles is to remove triglycerides from the blood for storage in both adipose tissue as well as muscle cells. Obese people generally have much more lipoprotein lipase activity in their adipose cells than lean people do. This high LPL activity makes fat storage very efficient. Even small excesses in energy intake or excess calories have a more dramatic impact on obese people than on lean people. With weight loss, what's been shown is that this LPL activity will actually increase and that it encourages the body to try to store more fat. Because of this, it makes it very, very easy to regain weight that has been lost. The activity of this particular enzyme, this LPL enzyme, as well as other body proteins, are thought to play significant roles in their attempt to keep our body weight at what we refer to as a set point. What often happens is after a period of weight loss or even weight gain, the body adjusts its metabolism to try to get back to the original weight. It's thought that the human body uses its own internal controls to try to maintain that particular weight.
I just noted the enzyme lipoprotein lipase and its role in fat metabolism. But why do some people produce more of this enzyme or body protein than others? Is there a genetic component? This next section describes other body proteins that may also better explain appetite control, energy regulation, as well as obesity development. The first one we'll take a look at is known as leptin. We have what has been identified as an obesity gene, an OB gene, that is primarily active in our adipose tissue. This gene codes for a body protein known as leptin. Leptin acts primarily as a hormone in our hypothalamus. Remember our hypothalamus, the control center for eating. Leptin helps to regulate food intake as well as energy expenditure or calorie burn in response to adipose tissue. When body fat increases, leptin increases, which in turn suppresses appetite. When body fat decreases, leptin decreases, which in turn stimulates our appetite and suppresses our energy expenditure. This OB gene was first identified in mice, and it was found that mice who have a defect in this gene cause them to become morbidly obese. When they were treated with leptin injections, their appetite decreased, or it was basically suppressed, and their overall body fat percentage also decreased. Now, studies subsequently showed, however, that leptin deficiency is not very common in humans. There's a small percentage of the population that if they are truly leptin deficient, they will respond to leptin injections, which in turn would help to regulate body weight. There has been identified, though, another condition which is known as leptin resistance, and this is more likely to occur. If someone has leptin resistance, it results in an increase in leptin levels and a decrease in leptin sensitivity. So basically, you're producing large amounts of leptin, but it is not being efficiently used. There has been an important component which has been identified which can actually influence this leptin resistance, and that is excessive fructose consumption, especially in the form of high fructose corn syrup. This has been shown through various studies that it can induce this leptin resistance, which then in turn can increase body fat percentage. So think about where we get a large amount of our high fructose corn syrup from. A lot of the sugary drinks that we consume, it's added very frequently to processed foods, so we constantly are being exposed to large amounts of this particular ingredient. Here's a great visual of how a leptin deficiency affects body fat percentage. On the left, that's a mouse who has a true leptin deficiency. He weighs, on average, about 3 times as much as a normal mouse. If you look at the mouse on the right, he also has a leptin deficiency, but he's been treated with leptin injections. You could see that he is significantly smaller, although he still is a little bit larger than your average or normal mouse. Another body protein to note is ghrelin. Ghrelin acts primarily as a hormone in the hypothalamus, once again in the control center of the brain. Whereas leptin is produced in fat cells or adipose tissue, ghrelin is secreted mainly by stomach cells. Its role is to increase before a meal and decrease after a meal. What this does then is it can reflect the hunger that we feel before a meal, and then also influence the satiety that we should be feeling following our eating pattern. What's been found, however, is that in certain obese populations, these levels do not decline as much as in those who tend to be in a lean population or a healthy body percentage. What that means then is there's a miscommunication between the brain as well as the GI tract. So someone who has an issue with these ghrelin levels, they continue to eat. They're not picking up the signal that they should be full. Some research also has shown that ghrelin is associated with our sleeping patterns. In fact, a lack of sleep has been found to not only increase ghrelin, which is referred to as the hunger hormone, but it also decreases leptin, which is often referred to as the satiety hormone. Because of the large amount of people, especially in the United States, that don't get adequate sleep, it makes you wonder if there is a true connection between sleeping and the production of these hormones. Genes also code for proteins which are involved in energy metabolism. These proteins, which are referred to as uncoupling proteins, can influence the storing or the expending of energy within our different types of body fat. The body has different types of adipose tissue, and they are referred to as either white adipose tissue or brown adipose tissue. White adipose tissue stores fat for other cells to use as a source of energy. On the other hand, brown adipose tissue releases energy, specifically in the form of heat, due to uncoupled reactions which rely on these uncoupling proteins. Therefore, energy is being burned and it is not being stored within the cells themselves. This visual shows you the difference between white versus brown adipose tissue. On the right, the white adipose tissue, if you know, is containing large amounts of fat cells. Those fat cells are completely full of fat, which is going to be saved or stored as a source of energy. On the left, there's an example of brown adipose tissue. And what you'll note here is that the fat cells are packed with mitochondria that produces heat. What that in turn does is it increases energy expenditure, and it also causes it to have that brown type of appearance. Research has shown that some people who are overweight or obese have less brown fat activity. Those uncoupling proteins which are necessary for this burning effect may be inefficient. Therefore, metabolism is going to be affected, and the result is a lower overall metabolic rate. The good news, however, is that some white adipose tissue can be turned brown. How? Through exercise. What's been shown is that muscle cells can release a protein, which is known as irisin. And what this protein can do is trigger the browning effect, resulting in what are known as bright adipocytes. These in turn can burn energy and therefore help with overall weight management. Another factor being investigated is the relationship with our gut microbiome and its ability to also influence the browning of white adipose tissue. Studies here have shown that the obese population may have a microbiome that contain a lower amount of the good microbes, which are necessary for this browning effect. So what does this mean? Well, we need to pay attention to keeping our gut healthy, including those foods which we identified in Chapter 3 that can be probiotic or prebiotic sources. Obviously, genes don't work alone in the development of obesity. There are other factors which certainly come into play or contribute to what we refer to as an obesogenic environment. These include increased food intake, unhealthy choices, as well as decreased physical activity. First, let's take a look at overall dietary effects. Our environment on a daily basis exposes us to an abundance of high-calorie, high-fat foods. Think about fast foods, think about convenience foods that are readily available. They also tend to be relatively inexpensive, and they are heavily advertised. On top of that, more often than not, they simply taste good. All of these factors cause us to ignore the satiety signals within our body and leads to overeating. Another factor is the supersize concept. Portion sizes in the United States are generally 2 to 8 times larger than standard serving sizes. Our portion sizes are dramatically larger compared to other countries. Not surprisingly then, the tendency towards these larger portion sizes correlates directly to the increase in the overweight and obese population in the United States. The connection with physical activity, well, this is pretty easy to understand. If someone is taking in an excess amount of calories and their physical activity is low, it's going to lead to weight gain. The more time people spend in sedentary types of activities, the more likely they are to be overweight or obese. Then we also have to consider psychological factors. Have already talked previously about how stress, anxiety, emotions can often cause us to override those satiety signals. Another factor is what's referred to as the clean your plate syndrome, which is often initiated during our childhood. If someone was forced to sit at the table as a child until you finished everything on your plate, that can set you up for overeating as you go into adulthood. Even though your body is telling you you're full, you feel pressured to consume everything that is put in front of you. Again, overriding that feeling of fullness and therefore leading to additional weight gain. Let's take a look now at what interventions we often turn to for weight loss or management. As consumers, we need to be careful not to fall victim to some diet claiming to do it all. If it sounds too good to be true, it probably is. There is no quick fix. You didn't gain weight overnight, and it's not going to come off overnight. Our metabolisms are much too complicated for such an effect to occur in a healthy manner. Some of these fad diets can produce side effects. They can include heart arrhythmias, acid-base imbalance, fatigue, constipation, gallstones can develop, and in some cases, some fad diets have proved to be fatal. I would encourage you to take a look at Highlight 9, which is at the end of Chapter 9, and it offers some very sound guidelines for identifying bogus or dangerous fad or weight loss diets. Another intervention which is often turned to is what is known as the low-carb, high-protein diet. And after going through Chapter 7 and going through metabolism, you can understand this whole concept a bit better. These types of diets lead to a rapid weight loss, initially due to losing glycogen as well as water. You're then shifted into that state of ketosis, which occurs due to not having adequate carbohydrate available. In addition, without that adequate dietary carbohydrate, you deplete your glycogen stores. Our body will then turn to our fat stores, and eventually metabolize them in an abnormal manner. The result then is the production of ketones, which your body can use for a certain period of time as a source of energy. Some of the potential side effects: electrolyte imbalance, acid-base imbalance, and there may be some calcium, which is also being lost from your bones. Short-term period, it's not shown to be dramatically unhealthy. However, long-term effects are unknown at the present time. In addition to diets, people often turn to weight loss products. Take a moment to look at the next two slides for some of the common over-the-counter products which are available. The possible side effects of these may be surprising or even alarming. These products do not need FDA approval, so there is no guarantee that they are either effective or safe. Consumers cannot assume that a dietary supplement is okay to use just because it's on the market. Before using any dietary supplement for weight loss, it's highly recommended that you consult with a physician or a dietitian. Again, just take a few moments to look at these additional over-the-counter products which are available, and again, the potential side effects which may occur. There are some products which have been approved by the FDA. One commonly used is Orlistat, which is marketed as Ally. This works in a way to block fat digestion, which in turn decreases fat absorption. What that means then is that some fat molecules will travel through your GI tract intact. Because of that, though, there can be potential side effects. It can result in frequent bowel movements, production of excess gas, as well as reduced absorption of fat-soluble vitamins. It's important, therefore, then to actually modify your fat intake to some extent if you're using this particular product. Another product approved by the FDA is known as Phentermine, or Adipex P. This particular medication, however, is by prescription only, and it acts as an appetite suppressant by altering brain chemicals that affect both our mood and appetite. What it does is it increases serotonin or catecholamine, which in turn affects those two factors. It typically is used for no more than 12 weeks, and it's important that its use is coupled with exercise as well as a calorie-controlled diet. There are potential side effects which can occur: dry mouth, sleeping issues, nausea, vomiting, diarrhea. There can be heart arrhythmias that can develop, blood pressure can be affected. The positive, however, is that since it is being prescribed by a doctor, one is going to be medically monitored. So identifying these side effects would be done at a fairly quick rate. A more aggressive intervention for obesity is to turn to bariatric surgery. There are certain factors, however, which need to be apparent to approve someone for one of the following procedures that we're going to discuss. They include, first of all, having tried other weight loss measures incorporating diet and exercise and not being successful. If someone's BMI is greater than 40, or if it's greater than 35, and they have already developed some weight-related medical issues, consider things like heart disease, diabetes, that also would be a factor which would lead to approval for this surgery. There also needs to be no medical or psychological contraindications which would affect the success of this particular surgical plan. One also needs to understand any of the risks involved with surgery, as well as having a strong motivation to then follow what's necessary post-surgery when it comes to both the dietary plan and physical activity. So the first procedure that we'll take a look at is gastric bypass. With gastric bypass, the size of the stomach is reduced. When that occurs, it also reduces the amount of ghrelin that's being synthesized. And remember, ghrelin, that's what we refer to as that hunger hormone. There's now a new connection that's going to be created directly to the small intestine. Some of the possible side effects can include infection, diarrhea, cramping, the development of gallstones, kidney stones, as well as various nutrient deficiencies. This type of a procedure is going to require a drastic change in one's dietary intake. The size of the stomach is so small that it cannot hold larger amounts of food or liquid at any given time. We're going to take a look visually at gastric bypass in just a minute. The second type of surgical procedure to note is what is referred to as gastric banding or a lap band. In this procedure, the surgeon creates a small gastric pouch using an inflatable band placed near the top of the stomach. The band is tightened or loosened by adding or removing fluid, usually saline, through an access port which is placed directly under the skin. This procedure is done laparoscopically, so there's less surgical risk involved. With gastric banding also, there tends to be less risk of developing nutrient deficiencies, and side effects tend to be more minimal as long as one sticks with the proper dietary plan. The third type of procedure is what's known as a gastric sleeve or sleeve gastrectomy. In this case, more than 50% of the stomach is removed, and in some cases it can go up as high as 85% of the stomach being removed. What's left is almost a thin vertical type sleeve, which often is referred to as being about the size of a banana. This type of surgery is more commonly being done now laparoscopically. It also does have some possible side effects: bleeding, infection, diarrhea, and so forth. And as with the other two procedures, it requires dietary changes to reduce the potential side effects as well as to ensure success with weight loss. Take a few moments to review this slide, which visually shows how these three surgical procedures compare. They all reduce the size of the stomach significantly, therefore affecting how much one can eat. You can see why it's important then to change eating habits dramatically for long-term success in weight loss. We've looked at several factors contributing to weight gain or specifically development of obesity, and you can see it's a complex process. Successful treatment is also a complex process. What strategies have produced the most successful results? Well, that's what we'll take a look at now. Healthy eating pattern is important, reasonable expectations, physical activity, and permanent lifestyle changes are important for achieving permanent weight loss. As a guideline, a plan which allows for a weight loss pattern of about 1/2 to 2 pounds per week, or 5 to 10% of body weight over the course of 6 months, is what's considered most effective and safe.
There
are 3 recommended weight loss strategies that have been found to help one be successful. The first strategy to note is a moderate calorie restricted diet. Notice that it is not termed as a severe restriction. If you know your BMI, use this as your starting point. If your BMI is between 27 and 35, the recommendation is to reduce your typical intake by 500 calories. If your BMI is greater than 35, you can reduce your intake by anywhere between 500 to 1,000 calories a day. These reductions have been shown to help reduce body fat percentage while helping to retain lean tissue or muscle. You also want to make sure that you can include foods that are nutrient dense. Work in foods that you actually like. You're not going to stick with the guideline if you don't like the foods that are being offered. If you restrict your intake only moderately, it will help to minimize issues with hunger and still provide you with enough energy so you're not tired all the time. This moderate calorie restriction should really be the jump board for an eating pattern you can stick with in the long term. Here's a few additional suggestions to work along with a moderate calorie restriction. Include high fiber and complex carbohydrates. Why? Well, these categories help to fill you up and they empty slowly from the stomach. Water is an important component. It can also provide you with a feeling of fullness. It potentially can reduce hunger and therefore reduce your overall intake. Water is also important to help excrete the byproducts which are produced by the fat breakdown that occurs during weight loss. Remember again, you don't want a severe calorie restriction. The lower limit of a restriction should be 1,200 calories. Below this increases the risk of nutrient deficiency. Include breakfast. Studies have shown that breakfast is inversely related to obesity. It's also been shown that people who eat breakfast on a regular basis have a lower risk of things like elevations in blood pressure, elevations in blood lipid levels, and also have an overall lower BMI. Also include smaller portions of food and slow down. Consume it at a slower rate. Give the stomach time to signal to the brain that you are actually experiencing satiety. Lastly, watch empty calories. Watch your consumption of foods that provide you with nothing but a source of calories. So things like soda, things like potato chips, which really have no nutritional value, but contribute a large amount of calories. Alcohol also falls under this same category. The second recommended weight loss strategy is physical activity. Weight loss has been shown to be more effective when coupled with physical activity or exercise. Think about how physical activity can produce the browning effect of white adipose tissue, which in turn will then burn fat instead of storing it. We discussed this concept back in the information on the uncoupling proteins. Aerobic activity in particular allows for constant oxygen supply, which makes fat burning also more effective. Weight bearing or strength training, resistance training can help improve muscle mass. With an increase in muscle mass percentages, metabolism can also be increased. Overall, a BMR, a basal metabolic rate, has been found to increase with any type of physical activity, whether it's aerobic or whether it is strength training or resistance training. Another positive is that exercise or physical activity can help to curb your appetite to some extent. Glucose and fatty acids are mobilized from their storage sites within the body. They then become abundant in the bloodstream, which in turn can help to suppress digestive functions. The last positive when we're talking about physical activity is that overall it can reduce stress and improve self-esteem, which those two in of themselves can help with a successful weight loss program. The third important component of successful weight loss or management is behavior modification. Behavior modification focuses on how to change behaviors specifically to decrease energy intake as well as increase energy expenditure. It certainly is a method which requires much time and effort, but it is necessary, again, for successful weight loss or maintenance. Awareness of your behaviors is very important. You have to identify triggers. So what, for example, makes you eat every night at 10 p.m.? Is it boredom? Is it stress? Is it anxiety? What can help to track food as well as emotions is to keep a food diary, or even the food tracker apps that are available can be helpful in managing overall intake. Once you identify the trigger, then you can put a plan in progress, starting with small measurable goals. So for example, you can decide to walk, say 15 minutes every day after dinner. The key is to practice the desired behavior, in this case walking, until they finally do become routine. There are many other strategies that can be used to change behavior involving eating based on an individual. A few that we can note is get in the habit of using smaller plates. This encourages smaller portions. If you use a larger plate, this tempts you to put larger portions and can actually disrupt what a suggested serving may be. Don't grocery shop when you're hungry. How many times have we done this? And we find that we end up with everything in the store basically in the shopping cart. If we plan grocery trips, make a list and stick to them, it could cut down on the Oreos or the ice cream that eventually end up in our cart. Limit the areas for eating. For example, if you pick up food and walk all around the house, you don't focus on the amount consumed. The same principle applies to separating eating from other activities. Again, what can happen is you sit down to watch TV with a bag of chips, and before you know it, the bag is gone. This is sometimes referred to as mindless eating, and it is a very major culprit in overall weight gain. The last thing to note is the use of support groups. Support groups can provide quite a deal of assistance when making lifestyle changes and dietary changes. Structured programs in particular, such as Weight Watchers and Overeaters Anonymous, have proved very beneficial, once again, for successful weight loss or weight maintenance. From all the information we've reviewed, you can see that there is no magic bullet for weight loss. Usually, a combination of approaches appears to be the most effective. Healthy diet combined with physical activity, combined with behavior modification are key. To help change the direction of our increasing weight in the United States, health organizations have developed what are known as national strategies to prevent obesity. Take a moment and look at what is being promoted to assure us of a healthier future.